Hello students, so in the last lecture we discussed elastic potential energy. What is the formula for, see first we revise what is the elastic potential energy. And what is the meaning by elastic potential energy? When wire is stretched or compressed, then during that process work is done, and that work is stored in the form of energy of wire. Okay, so and that work have two formula. First, half stress into strength into volume. And what is the second formula in terms of Young modulus? That is half YA by L into delta L square. Okay, this is in the terms of Young modulus. And then second formula is about what? Energy density. And for energy density, what is the formula? Half stress into strength. Okay, what is the second formula? Half stress into strength. So students, that is elastic potential energy and energy density, right? Now see numericals. What is the question? Two wires of same material and same length, but diameters in the ratio of 1/2. Means see students, there are the two wires of same material and length. Okay, there are the two wires of same material and length, two wires of same material and length, but diameters in the ratio. What is the ratio of diameter? One by two are stretched by the same force. Both wires are stretched by same force. Both wires are stretched by same force. The potential energy per unit volume of the two wires will be in the ratio. Find ratio of potential energy per unit volume of two wires. Okay, find ratio of potential energy per unit volume of two wires. Clear? So we want to find what? We want to find ratio of potential energy per unit volume of two wires. So two wires of same material and length, and what is the ratio of diameter? 1/2. Both wires are stretched by same force. Both wires are stretched by same force. Find the ratio of potential energy per unit volume of the two wires. Okay, we want to find what? Ratio of potential energy per unit volume of two wires. So how to find students, how to find ratio of potential energy per unit volume? So first of all, students, see ratio of potential energy per unit volume. So potential energy per unit volume is what? Energy density, right? So we want to find ratio of energy density, because potential energy per unit volume is known as energy density. See, two wires of same material. So same material means what, students? Y same. And two wires of same material, because Young modulus depends on the material, but material same. For two wire, material same. So Young modulus same and length same. Same material, same length. Both wires are stretched by same force, so F same. But diameter different, so area must be different. Now what is the formula for energy density? Stress into strain. Okay, stress into strain. See, students, strain means what? Delta L by L. Now see how to solve it. Stress means what? Strain means what? Delta L by L. But see, students, length is given, length is same, but not about delta L. અહીંયા તમને કંઈ ડેલ્ટા એલની ઇન્ફોર્મેશન નથી. ઓકે, સો ઇટ મીન્સ આપણે સ્ટ્રેનને રિપ્લેસ કરવું પડે, because here delta L is missing, change in length. So we replace the strain. What is the formula? Young modulus is equals to stress by strain. So strain is equals to stress by Young modulus. So see, here we write what? In the place of strain, we write what? Stress upon Young modulus. Now what is meaning by stress? Force by area, and two stress are there, so force by area square. Chalo, force cancel, force same, Young modulus same. So now F square or A square. And what is the area of cross section area of wire? Wire cross section area of wire is circular, so pi r square, and here area square. So see, density is proportional to what? R raised to 4. Density is because 2 and force same, Young modulus same, so density is inversely proportional to what? R raised to 4. But here diameter is given. So see, students, it is the same thing, because radius is what? Diameter by 2. So R1 by R2, D1 by D2. है ना? 2 cancel. So what is D1 by D2? 1 by 2. So rho 1 by rho 2. So here inversely relation, rho is energy density, here inversely relation, so 1, so here we write 2, so here we write 1. What is R1 by R2? 1 by 2. So what is R2 by R1? 2 by 1. So what is the answer? 16 by 1. Okay, what is the answer, students? 16 by 1. Clear? Any doubt? Okay, chalo. So what is the answer for energy density? 16 by 1. Chalo. Now see, students, same type of question asked in an exam. Now what is the question? See students, that question asked in 2015. Students, there are the two wires, steel and brass. Chalo, two wires of same length and same area. Chalo, so length is same, area is same. But see students, the young modulus are different because materials are different. If we want the lower end of the wires to be at same level, lower ends of the wire at same level, so delta L is same. Okay, if you want the lower ends of the wire to be at the same level, then the weight added to the steel and brass wires must be in the ratio then the weights added to the steel and brass wires must be in the ratio of then the weights added to the, because when weight is added students, wire is extend but the lower end at the same level, so it means extension is same, delta L is same. Okay, extension is same. Okay, if we connect the weight, suppose if we connect the weight, some weight block, then length is increased but the lower end at the same level, so it means delta L is same. So, and what is the given? Young modulus of steel wire is double than the young modulus of brass wire. And our options are 4/1, 1/1, 1/2 or 2/1. Okay, so students, there are the two wires, steel and brass wire. Lower end of the wires at the same level. Okay, lower ends of the wire at the same level means delta L same. Then the weights added to the steel and brass wire must be in the ratio of. Chalo, so we want to find ratio of weight in both the wires. Okay. Chalo, so how to find? See students, one is steel wire, another is brass wire, delta L is same, young modulus is given, so we start from the young modulus, F by A delta L by L, so FL is equals to A delta L. Now see students, here force is equals to what? Weight of the body. Okay, here what is the force on a wire? It is weight of the body. So instead of force we can write weight of the body. Chalo, so what is the weight? YA delta L by L. Okay, here force on the wire is what? It is weight of the body. Chalo, so see students, now it is very easy question. Length same, delta L same, because they are lower end of the wire at the same level. It means delta L same, area same. So we can say that W is not work done, it is weight, and weight is here directly proportional to Young modulus. Chalo, so weight in a steel wire, okay, because then the weight added to the steel and brass wire. So first we write steel wire, then weight in a brass wire, directly proportional, so steel, so here steel, here brass. What is the Young modulus of steel wire? Double than the bulk modulus of brass wire, so 2/1. Okay, so what is the answer, students? Answer is 2/1. Clear? So now next next question, see. Two wires of equal length and cross-sectional area are suspended as shown in the figure. The Young modulus are Y1 and Y2 respectively. The equivalent Young modulus will be. So suppose there are the two wires. Chalo. Okay, so two wires of same length and two wires of same length and same cross-sectional area. Two wires of same length and same cross-sectional area. And what are the Young modulus? Here Young modulus is Y1, here Young modulus is Y2. The equivalent Young modulus will be. Chalo, so we want to find equivalent Young modulus. We want to find what, students? We want to find equivalent Young modulus. Chalo, so how to find equivalent Young modulus? See, what are the options? Y1 plus Y2/2, Y1 plus Y2, Y1 Y2 upon Y1 plus Y2. Chalo. So how to find, students? See, first both wires are connected in parallel. So see, students, now what is the for equivalent Young modulus? First of all, see what is the relation between spring constant and Young modulus, because as we know, when two wires are connected in parallel, then what is the equivalent spring constant? K is equal to K1 plus K2. Barabar? For what? For parallel connection. As we know, we study in oscillation, students, in a series connection, direct addition, in parallel in series connection, reciprocal addition of spring constant, and in parallel connection direct addition of spring constant. But see students, here we want to write an equivalent Young modulus. So what is the relation between K and Young modulus? That is what? K is equals to Y A by L. Okay, that we'll study in a oscillation. K is equals to what? Y A by L. Okay, see, अगर students भुलाई गयु होय, then we prove also here. See, Young modulus is equals to F by A delta L by L. So FL upon A delta L. Now F is a restoring force. F is equal to Kx, but here delta L, because here delta L is it what? Displacement, increase in length. So here we write K delta L. Delta L cancel. So take K as a subject. So take K as a subject. So we get Y A by L. So students, see, here we write what? Both the wires have a same Young modulus. Both the wires have a same length and same cross section area. So here we write what? Y1 A by L. Here we write what? Y2 A by L. But here we write what, students? Equivalent. So see students, think when both the wires are combined, equivalent, parallel connection, and both the wires are combined, then area is becomes what? 2A. Okay, see, then area, because when we combine, then its cross section area becomes 2A. Length is same, but cross section area becomes 2A. Suppose see, these are the two wires. Okay, so first what is the area? Cross section area 2A, but when we combine in a parallel, then see the cross section area becomes double. Okay, but length remains same. Length remains same, but cross section area becomes double. First they are individual. Now when we connect in a parallel, so what is the cross section area? 2A. Length remains same. If we connect in a series, then see, cross section area remains same, but length becomes double. Okay, chalo. So here we consider what for equivalent spring constant. Here we consider what? Y. This Y is what? Equivalent Young modulus. But what is the area that we consider here? 2A. And what is the length? L. Okay, chalo. So now A by L and cancel. So 2 into Y, Y1 plus Y2. So what is the Young modulus? Y1 plus Y2 by 2. Okay, what is the Young modulus? Y1 plus Y2 by 2. Now see students, one more question that is different. Now what is the question? See, a thick pipe of length 5 meter a thick pipe of length 5 meter. What is the length of pipe? 5 meter. A thick pipe of length 5 meter is made of rubber. Okay, it's made from what? Rubber. Having Young modulus 2 into 6 Newton per meter square, and what is the density of this material? 1500 kilogram per meter cube. Chalo, now what? It is held in a vertical position when suspended from a ceiling. Now it is held in a vertical position now this is the what? The thick wire. It is held in a vertical position, and one end is attached to the ceiling. Calculate the extension produced in a pipe under its own weight. Under its own weight means here we not connect the block because it is a rubber pipe. So now this pipe is extended due to its own weight. Okay, chalo. So see students, very much important question. Here we cannot connect any type of block. Okay, અહીંયા આવો કંઈ બ્લોક નથી, so એનું extension થાય. So we want to find what? Chalo, we want to find extension in wire. We want to find extension in a wire due to its own weight. Okay, we want to find extension in wire due to its own weight. Chalo, so we want to find extension means we want to find delta L. Okay, you want to find what? Extension in wire due to its own weight. So see students, what is the major concept? See, what is its total length? Suppose right now capital L. So what is the formula? As we know, Young modulus is given. So longitudinal stress means F by A upon longitudinal strain, delta L by L. So we write FL upon A delta L, FL upon A delta L. Now we want to find so we write FL upon A delta L. Now we want to find delta L student. So FL upon AY. But see students, here what is the force? Here force is what? mg. But because this is what? own weight of wire. It is own weight of wire. Okay, so now see student, at always when we consider own weight of wire, then it is considered from its center of mass. Okay, own weight of the wire when block is not there. Again I repeat, अगर suppose અહીંયા block હોત ને students, તો આપણે અત્યાર સુધી આખી તો આપણે ટોટલ લેન્થ જ કન્સિડર કરવી પડે. અગર બ્લોક હોય તો if block is there, then we consider its total length of wire. But whenever we consider, if block is not there, and if we consider open weight of wire, then we always consider length from its center of mass. So we consider length is what? L by 2. Okay, always remember, if block is connected with the wire, then we consider total length, જેવું આપણે અત્યાર સુધી કર્યું. But if extension in length due to its own weight of the wire, then we consider what? Then we consider it length from its center of mass. So we consider the length is what? L by 2. When extension of wire is due to its own length. Chalo, so here we consider L by 2. So mg upon ay. આ એકવાર એટલું ફોર્મ્યુલા પૂછાણી છે. ઓકે, સો mgl upon ay. ચલો, so now place all the values, students. Okay, again one problem, density is not given, mass is not given. So density is equal to mass by volume. So volume is equals to what? Area into length. So area into length and what is the length of wire? 5 meter. What is the total length of wire? Small l. Okay, so total length of wire is small l, and here we consider what? Half of its length. Why? Here we consider what? Half of its length. Why? Because extension in wire is due to its own weight. So whenever the extension in wire is due to its own weight, then we measure the then gravitational force is measured from what? Its center of mass. So that's why we consider L by 2. Chalo, so now place all the values, students. A cancel. What is the density? 1500. So 15 into 10 raised to 2. Length 5. Again length 5. Young modulus 10 raised to 6 divided by 2. So final answer is 0.1875. So this is the question when there is an extension in wire due to its own weight. Chalo, now next students, next we discuss new topic. That is Poisson's ratio. Chalo, now we discuss what? Poisson ratio. Chalo, so see students, how to define Poisson's ratio C. Now it is important concept, students. Suppose this is the wire, okay, L. Now students think, when wire is stretched, suppose when perpendicular force is applied and wire is stretched, then length of wire is increased, but the other dimension like radius, diameter, thickness are decreased. ये आपने consider नहीं की होती है सुधी, है ना? Suppose if we stretch the wire, then length of wire is increased. Now see, length of wire is increased. What is the length? L plus delta L. But see, its other dimension. See, cross section area is become small. So it means radius decreased. Okay, see, now radius is becomes very small. Ahiya jo, this is the radius. Okay, so now what can we see when wire is stretched, then length of wire is increased, but other dimensions like radius, diameter, thickness are what? Decreased. But other diameter like radius, diameter are what? Decreased. So when wire is stretched, length of wire is increased, but other dimensions like radius, diameter are what? Decreased. So students, that is known as what? Lateral strain. Okay, that is known as what? Lateral strain. Lateral strain means what? Change in dimension by original dimension. Lateral strain means what, students? Change in dimension by original dimension means delta R by R, means change in radius by original radius, or we can write in this way. This is what? Change in diameter by original diameter. Okay, so that is the meaning by lateral strain. Okay, what is the concept, students? When wire is stretched, then length of wire is increased, but the other dimension like radius, see, the cross section becomes small. See, compared to both, here cross section becomes small, so it means radius, diameter are decreased. So that is known as lateral strain. So lateral strain means, longitudinal strain means what? Delta L by L, but lateral strain means what? Delta R by R, means change in radius by original radius, change in diameter by original diameter. Okay, chalo. So now we define Poisson ratio. Its symbol is sigma. Means what, students? Means lateral strain by longitudinal strain. Okay, it is the ratio of it is the what? Ratio of lateral strain by longitudinal strain. Now lateral strain means what? Delta R by R, and longitudinal strain means delta L by L. But students, here we place negative sign. Why? Because when length is increased, radius and diameter are decreased. Okay, chalo, so we can write this formula now in this way: delta R by R minus sigma means Poisson ratio. In many type ratio, symbol of Poisson ratio is also mu. Okay, so confusion na thata, mu પણ કહેવાય આને. And we can also write in this way, students: delta D by D. Delta D by D means what? Change in diameter by original diameter. So these are the two formula for Poisson ratio. Now we define one formula for cylindrical wire also. Now students, we discuss one formula for cylindrical wire. Suppose this is the cylindrical wire. Okay, length of wire is what? L, and what is the radius of cross section of wire is what? R. Sure. So now see students, how to define, suppose what is the volume of wire. This is a very important formula, students, in the terms of Poisson ratio. Sure. Now what is the volume of wire? Sure. Now what is the volume of wire? V is equal to, what is the volume of wire? V is equals to pi R square L. What is the volume of wire? V is equals to pi R square L. Sure. So delta V by V, pi constant, delta V by V. Pi is a constant, student, so delta V by V, pi constant, so R square into L, R square into L. So we write what? 2 delta R by L. Okay. See, the delta V by V is known as fractional change in volume. Also, it is known as volume strain. Delta R by R is lateral strain. Delta L by L is known as longitudinal strain. Okay. Pi is constant, so no need to write pi. And why it is 2? Because R square. So now see, what is the formula? As we discussed, delta R by R is minus sigma delta L by L. See here, delta R by R is equal to what? Minus sigma delta L by L. Chalo, now in the place of delta R by R we write minus sigma delta L by L. So delta V by V, delta L by L common, minus 2 sigma plus 1. So we can write this in this way. 1 minus 2 sigma. So students, remember this formula. Okay, this is the relation between volume strain, longitudinal strain and Poisson ratio. So what is the formula? Delta V by V is equal to delta L by L. Delta V by V is equal to delta L by L and in bracket 1 minus 2 sigma. Okay, where sigma is what? Poisson ratio. So, and students, from this formula we can say that value of Poisson ratio is what? Value of Poisson ratio is less than 0.5. Why? Because if we take 0.5, then it becomes 0. 2 into 0.5, 1. So 1 minus 1, 0. If we take more than 0.5, then it becomes negative. Okay. So see, if we take 2 into suppose 0.6, then 1.2, 1 minus 1.2, so it becomes negative. So value of Poisson ratio sigma is what? Less than 1 by 2. So ideally it is between 0 to 1 by 2. Okay, value of Poisson ratio is what? 0 to 1 by 2. Because if we take 1 by 2, then it becomes whole answer 0. If we take greater than 1 by 2, then it becomes negative. So its value is between what? 0 to 1 by 2. And remember this formula, this is very important. Delta V by V is equal to 1 minus 2 sigma. So now see one question. A material has Poisson ratio sigma is Poisson ratio is what? 0.4. If a uniform road if a uniform road suffers a longitudinal strain of 2 into 10 raised to minus 3 meter. Okay, now what is the longitudinal strain in a road? Is 2 into 10 raised to minus 3. Find percentage change in a volume. Chalo. A material has a Poisson ratio. What is its value? 0.4. Longitudinal strain in a rod is 2 into 10 raised to minus 3. Find percentage change in a volume. Chalo, we want to find percentage change in a volume. Chalo, a material has Poisson ratio 0.4, longitudinal strain delta L by L is 2 into 10 raised to minus 3. Find percentage change in a volume, means we want to find delta V by V. Okay, we want to find delta V by V. Chalo. So see students, we want to find delta V by V, and how to find delta V by V? What is the Poisson ratio? 0.4. Longitudinal strain means delta L by L is 2 into 10 raised to minus 3. We want to find delta V by V, means delta V by V means percentage error. Delta V by V is fractional error. If multiplied by it, then it is percentage error, otherwise it is known as volume strain. Chalo, so what is the formula that we discussed students? Delta V by V is equals to, means volume strain, longitudinal strain 1 minus 2 sigma. Remember this formula. Okay, it is the relation between volume strain, longitudinal strain. And what is delta L by L? 2 into 10 raised to minus 3. What is sigma? 0.4. So 2 into 10 raised to minus 3, 1 minus 0.8. So 2 into 10 raised to minus 3. 1 minus 0.8 means 0.2. So 2 into 2.2. Chalo. So what we want to find? Percentage change students. So multiply by 100. What is the answer? 0.04 percentage. What is the answer? 0.04 percentage. That is what? Percentage change in Y. Okay. Chalo. So that is the Poisson ratio students. Remember its formula, delta V by V into delta L by L 1 minus 2 sigma. Chalo, now see one more important question. Chalo, now what is the question? A block of weight 10 Newton is attached to the one end of the wire of a cross-sectional area of 4 meters square. So now suppose this is the ball of weight 10 Newton. What is its weight? 10 Newton. What is the cross-sectional area of wire? Cross-sectional area of wire is 4 millimeters square. So convert into meter. So 4 into 10 raised to minus. Now, and is rotated in a vertical circle of a radius 30 centimeter. Is rotated in a vertical circle, means is rotated like that. Okay. Suppose here is one at another end, this is the wire, at another end block is connected, it weight W and is rotated in a vertical circle. This is like that. Okay, if moving like that, then it is a vertical circle. Moving like that, it is a vertical circle. Moving like that, it is a horizontal circle. Okay. Chalo, but it is what? Vertical circle. Moving like that. Vertical circle. Okay, it is a vertical circle. Chalo, so now the speed of the block at the bottom of the circle is 3 meter per second. Speed is in direction of the tangent. And what is the speed? 3 meter per second. Find the elongation. Find the elongation of the wire when the block is at the bottom of the circle. Chalo, we want to find delta L. Chalo, we want to find delta L when block at what? Chalo, and what is the Young modulus of wire? That is 2 into 10 raised to 11 Pascal. Chalo, clear students. So what is the question? There is one block and rotating in the vertical circle. So students, due to the rotation, its length is increased. Chalo, so again it is starting from what? Young modulus is given, so starting from that formula, so FL by A delta L, we want to find delta L, so FL. See students, length and radius of circle of wire both are same, and what is that? 30 centimeter. Okay. Chalo, now we want to find elongation. So first of all, see students, L is given, area is given, Young modulus is given, but we do not know about the what? So see students, towards the center we know that tension downward mg, it moving in a vertical direction. So which force is more? Tension force is more. Okay, it moving in that direction, so tension force is more. So T minus mg is equal to resultant force. Okay, see how to find tension, how to find F. So see, it moving in a vertical circle, so tension upward, mg downward, but it moving in a vertical circle, so tension is more. So T minus mg is equal to resultant force, and what is the resultant force? mv square by r. It is centripetal force. Why? Because it is moving in a vertical circle, circular motion. So what is the resultant force? mv square by r. So T is equals to mg plus mv square by r. Now here from that formula, from this formula we can find tension force, then placed here. Okay. Chalo, from that, because now all the things are given, mass means your weight is given. So From now place in that formula, so we can get what? Tension force. Okay. Then place the value of tension here and find delta F. Okay, now students complete this question.